So now let's solve using improved Eulers. Notice that formula is there's a little bit more involved here, which means that this is going to give us a more accurate depiction of what's going on. And what it does, the difference here is that we are taking an average. We're taking that differential equation and we are evaluating it at that previous point, x and y. And then we're taking that differential equation and evaluating it at another point, x sub n plus 1, which is in our current step because we're in y sub n plus 1, plus this y star of n plus 1. And that y star is coming from Euler's method itself. So it's looking at that value. And then we're taking the average of those two and then multiplying it by h times y sub n. So let's do it. We're looking at that fourth example in your notes here. That is the same differential equation that we had up here. So we should get something really similar to that in our final answer. We're going to need 3 columns. We're going to need an x column, we're going to need a y column, and we're going to need a y star column. They're giving us the initial condition of 0, 1. We don't have a y star in this step, so you could leave it blank or you could just draw some lines in there just to, let you know that there's nothing going in there. Now, our x's are changing by the increment of 0.05. So we've got to set that formula up. It's going to be equals that last x plus that step size. So I'm going to reference that cell just to make it easier for me to change the step size. Don't forget the dollar signs in front of the column and the row. That way it keeps that column in that row. And we want to find y of 0.5 in the end. Now we need to compute what's going on in this y star before we figure out y. Remember that formula for y really depends on what y star is. Going back up here. So I've got to do this guy first, and then I'll be able to use this, referencing this. So that y sub n, move this over. So y sub n plus 1, which is going to be it's going to start in that second row of my table here, is equal to that previous y. Okay, notice it's the previous y, not the previous y star, plus the step size. Step size stays the same, so we need dollar signs, times it's that previous xy typed into that differential equation. So it's going to say that x squared, which is in A4, plus the previous y squared. Oops. Hit enter. So now we've got to type in our y. So our new y value is y sub n, which is 1, plus the step size, times some stuff. And that stuff is the differential equation evaluated at the last x plus the differential equation evaluated at this y star and this x, and all of that's divided by 2. So you really have to watch parentheses here. Make sure you're typing everything in correctly. So it's times a whole bunch of stuff. I'm going to put some parentheses here. So we need that x squared plus y squared So you can see that that last parentheses, it highlighted what's over here. I'm going to do it again so you can see. If I type it in, it does that quick highlight, so it shows you where it stopped here. So we're going to need another parentheses here because we have a whole bunch. So there's that function evaluated at 0, 1. Now we got to do that differential equation evaluated at x sub n plus 1, y sub n plus 1. So it's going to be plus another parentheses. We're using that current x and typing it into that differential equation. So it's going to be that 0.05 squared plus our yn. I'm going to have to use the arrow because of all of this is taking up where that place is. If you use the arrow button, do you see how it just highlighted the cell that I needed? So now this part of the expression is evaluating at the 0.5 and then the value that was here. I think it was 1.5 or 1.05. This is evaluating at 0, 1. I need one more parentheses to close everything. Excel is picky about that. Now we need to take all of that and divide by 2. And you've got a couple of ways to do that. I'm just going to go back to the front and I'm going to take that h value and divide it by 2 since all of that is multiplied together. So there's our y value. Now let's copy everything down. So you can see at a step size of 0.05, we got the value 2.06149. Your final answer will be in the Y column, not the Y star column. And if we needed more decimal places, we could highlight this and move that out, and it will give you quite a few decimal places. I'll go up so far. So if we wanted to compare this to what we got before, this gave us 2.06194. If we go back to using just Euler's, with a step size of 0.05, we got 1.93. Improved Euler's will give you a better answer, a more accurate answer than standard Euler's. Just for fun, let's do one more. We have this differential equation. Step size is the same thing. It's going to be 0.05. So let's walk through the process again. We're going to have an X column, we're going to have a Y column, and we are going to have a Y star column. That first set, that first ordered pair, will come from that initial condition. Our initial condition is 0, 1. we will not have a Y star, so I'm going to show that there's nothing in there by just drawing some dashes there. Excel doesn't like that, but I'm going to force it to do it anyway by hitting yes. We want to evaluate y of 0.5. So our formula here equals that previous 0 value, that x value, plus the increment size. So there we are. Now we've got to find y star first. So our y star formula is going to be the previous y. So we're going to go equals previous y plus step size. Don't forget the dollar signs. Times the differential equation evaluated at the previous point. So this guy's a little bit more involved. That's why I wanted to do this one. It looks like more fun. So it's going to be x times y. So it's x times y plus square root of y. To do square root in Excel, you can use SQRT. There we are. Now let's work on that y column. So y sub n plus 1 is going to look like this. I'm going to rewrite this to write h over 2 times that. So here's what I mean by tweaking this formula a little bit. Instead of taking that sum and dividing it by 2, what I'm doing is I'm dividing by 2 out here, so it's h over 2. And then I'm just putting parentheses around this, just to make it easier to type everything into Excel. So let's finish this example. We've got to figure out this y. So the formula says it is equal to the last formula, the last y value, plus our h divided by 2. Don't forget your dollar signs. And you can put it into the cell here. You have to click into it. If you use arrows, it moves to different cells. Or you can do it up here in this bar. You've got options. So divided by 2 times, and then it is the differential equation evaluated at 0, 1, that previous xy value. So the differential equation is x times y plus square root of y. Plus, and then the differential equation evaluated at this x value, which is 0.05, and this y star value. I'm going to put all of that in parentheses. So it's going to be x times y. Oh, excuse me, it's this x times y. And remember, this is going to be y star. And to get to that, because this has now kind of filled in where that lies, I have to use the arrow keys. And you can see it's highlighted that cell in the back with the moving dots. So xy plus square root of the y star. So there's my y star. You can see it's highlighted, that's C4. In my parentheses, hit enter. And then let's copy all of our formulas down. So then in this case, our final answer would be this guy. And we could get more decimal places by moving that out. So if we needed 5 or 6 decimal places, just making this larger gives us more decimal places to play with. And we could always change that if we go to format cells and then number. You can change to however many decimal places you want. If we wanted 30, we could do that. Notice the zeros here, which means it hasn't computed anything that far out yet. So we wouldn't see a difference there. So our final answer is 1.755997. I'm going to go quite a few decimal places there. And that's at the step size of 0.05. Okay, that answer is going to be in the Y column. It is not in the Y star column. Final answer.